Hello, and welcome to the first webinar of the AtScale Deep Dive webinar series. This new webinar series is designed for AtScale customers. Every 2 weeks, we will run a 30-minute presentation that will take a deep dive into an AtScale implementation. We will focus on topics that will help you understand AtScale's technology, plan your analytics projects, prepare your data for BI, and explain how to develop and deploy AtScale to make information available to your business users in the most efficient and performant way. I'm Carol Gunst, Director of Marketing at AtScale, and it's my pleasure to introduce you to our presenter, Kamlesh Sharma, Customer Success Manager at AtScale. In this first session, he will review AtScale's architecture and key features for enabling informed AtScale architecture and enterprise deployment decision-making. Just want to mention that all participants are in listen-only mode. We do want to open this up for Q&A if there's time at the end, so please add your questions in the box at the bottom of the screen and we'll take them at the end of the presentation. And now, let me hand it over to Kamlesh.
Thank you, Carol. Thank you for the introduction. Good afternoon, everyone. Thank you for joining. So let's get started. As Carol mentioned, and we will be reviewing the AtScale architecture, key features, and functionality. So you can go back and take a look at your AtScale architecture and enterprise deployment options you have with AtScale. Now, before we dive into AtScale architecture, I just wanted to review whenever we are making enterprise deployment decisions, we do have some enterprise goals in our mind. So typically, enterprise solutions, have certain goals. I have listed quite a few of them, as you can see on the screen. I have highlighted the top 5 from my own experience and from talking to AtScale customers on a daily basis. So if we look at the top 5 goals, in no specific order, performance is definitely at the top of the list. Then we have security, we have governance. Cost is a very important factor when deploying enterprise solutions, and then time to market. I don't want to undermine the other goals that are listed, such as reliability, maintainability, extensibility, audit, and automation. I think what makes enterprise deployment decisions challenging is accounting for growth. And ideally, we would like solutions to meet all of these goals, but in a real world, it is not always possible. So what do? We try and balance between these goals. We rank these goals and we try and achieve as many as possible. Now, traditionally, what I have seen in my personal experiences, solutions need to meet multiple goals. If you deploy a solution which meets just 1 or 2 of these goals, the shelf life of that solution is very limited. And sooner than later, you will be revisiting that solution. So I hope, I'm trying to set the context for the conversation. So we'll be looking at these enterprise goals and talking about how AtScale architecture and key features and functionality support you in realizing these goals. So with that said, let me go to the next slide, where we will review the current data architecture or solution characteristics with respect to the goals I had mentioned on the previous slide. What we have seen in the last decade is, just from a data architecture and BI perspective, there has been shift. Now, a shift can be tactical, and then there are transformational shift. Migrating from traditional data warehouses or data platforms to big data was a transformational shift. What contributed to that shift was the volume of data people started to gather and needed to process. So there was an emergence of big data technologies. Now, if you look at big data technologies, I think pretty much everybody in the industry is working with big data technology, Hadoop, Cloudera, and so forth. So some of the characteristics of these big data technologies are, what did we gain with this big data technologies? What did it solve? What problems did it solve? So, from what I have listed on the screen here is definitely storage and batch processing scalability was a key area which big data technologies addressed. The cost went down. Now, cost is a very relative subject. There has to be a comparison point. What are you comparing to? But generally speaking, I think there is consensus that the cost went down. But the next two ones, which I have highlighted with question marks, performance, scalability, maintainability, and reliability, became questionable as people or companies started to adopt these big data platforms. And the time to market went up. And again, time to market is very subjective as well, because when we talk about time to market, we are talking about new technologies, resources, skill set needed, right? But just focusing on performance scalability, I think generally we will all agree that the big data platforms do not provide the performance scalability, especially from a data consumption standpoint, right? They're good at storing and batch processing, but when it comes to reading, the performance is not there, or it was not adequately, thought of when designing these big data solutions. Maintainability of the solutions and reliability of the solutions. I have personal experience with my prior employments where the reliability of these solutions is definitely questionable. So what are people doing to address performance scalability issues or challenges and the reliability issues? People or companies are now looking at the emergence of a new technology architecture, new data technology architecture, which is the cloud. There have been quite a few technology platforms that are available to you now: Snowflake, Redshift, Google BigQuery. So people are slowly, every customer I speak to on a daily basis is in some way, shape, or form talking about cloud, whether they have started that journey, they are in the evaluation process, or they have, moved their first project to the cloud. What is the cloud addressing? I think some of the challenges which we experienced with the big data technologies, such as performance scalability, the reliability and the maintainability of the solutions, the cloud technologies did try and address that. As you can see on the screen, the performance scalability is there. The cloud solutions are elastic in nature and they are automated. You don't have manual intervention if you want to scale, right? So that's a huge benefit. But what does that mean? It comes with a huge cost. There is a huge price tag that is associated with this solution if you want to scale performance horizontally. So when people are evaluating cloud technologies or trying to address some of the challenges they're experiencing with big data technologies, cost is a huge factor, is probably the number one factor that is being considered when people are, thinking about moving to the cloud. Of course, there's maintainability and reliability is good with the cloud infrastructure. Now, time to market, I have put a question mark there because I think we still need to prove. Again, it is very subjective based on the use case and what you're trying to move or the scale of the project, right? The time to market can still be a challenge. But just from a performance, scalability, and cost perspective, I have tried to lay out what is the general consensus. So with that, with these two technologies in play now, people are also thinking about hybrid approaches. Can I move some of my data to the cloud? Can I do it on-premise? Can I connect to my data on-premise And can I connect to my data in the cloud? So there are a lot of questions that people are seeking answers to in the backdrop of how the data architecture landscape has changed or is evolving. Let me go to the next slide. So let me just dive a little deeper into or bring in the BI landscape as well, right? So we talked about how the data architecture has changed, but the BI architecture or the BI landscape has changed as well, right? Because the data consumption needs to be there. People need data, and they need data quality. They need the data at the light of speed, right? So all of those challenges still exist, but how did the BI landscape changed? So on the left, what we are showing here is you have all these tools and technologies which were in existence probably 6, 7, 10 years back. I personally I have worked with Cognos, I have worked with Business Objects, I have worked with a technology called Actuate, I have worked with Click, right? So these were all good technologies a few years back, but they had their own inherent challenges. And they had challenges when it came to enterprise deployment, right? Some of the challenges are very common and they exist today as well. And those challenges are because all these technologies, they have some sort of semantic layer, like Cognos, you had a framework manager where you could model your data. In Business Objects, you had Universe where you could model your data. Now, if you're working in a silo, that's great. But if you're deploying or the data consumption is for the enterprise, or if you're creating an enterprise data warehouse and the data is getting consumed by different business units and LOBs, data quality matters a lot, right? And data access and security matters a lot. And with these tools and technologies having their own frameworks or semantic layers pose a lot of data quality and data trust challenges, because somebody would define a calculation in a certain way, get a different result, versus somebody reporting in Cognos would define the calculation in a different way and get a different result. So those traditional challenges are still existing, and they're definitely being addressed. Now, on the right, what we are showing here is, this is where I want to bring in the AtScale architecture, or where AtScale fits into the evolving data architecture and BI landscape. As you can see here, AtScale sits right in between the data layer and the consumption layer. Now, what I have mentioned here is just because of our positioning or where we sit in the architecture, AtScale is uniquely positioned to solve or mitigate data consumption and data engineering challenges, because we are connecting to both sides. We are connecting to the data layer, and we are also connecting to the, or letting the data consumption layer connect to us, right? So we are very uniquely positioned to solve or mitigate data consumption and data engineering challenges. And that is the, I just wanted to provide that context of, so that we can talk about how AtScale can help you meet your enterprise goal when it comes to enterprise solution deployments. So let's go to the next slide. This is a slide where we are showing that AtScale can connect to Snowflake. As some of you may be doing POCs, or you are familiar with the Snowflake architecture. You can have various data warehouses of different sizes, extra small, large, Excel, right? They come with their own compute and storage capacities. But AtScale, sitting in between the data layer and the consumption layer, is uniquely positioned to talk to Snowflake. And you will see what is the benefits of having AtScale in the center. Now, as I said, I kind of provided some context around key enterprise goals people have when designing enterprise solutions. So in this slide, we are talking about performance, scalability, and reliability. Now we're going to take a deep dive into at-scale feature sets that support these enterprise goals. The first one is the autonomous data engineering feature. That is the key feature and functionality of the at-scale platform. As you may be aware, people who are using at-scale, that AtScale allows you to create acceleration structures. Um, those structures are further classified into prediction-defined, user-defined, and demand-defined. What that means is you have control over, creating some structures by yourself if you know what you're doing, or primarily the system itself will look at your workload and the query patterns and do that autonomous data engineering, which is unmanageable if you want to do it yourself. As I said, I have a lot of experience working in the data and the BI space, and I have dealt with data engineering, or I have been part of the projects where we have attempted to do data engineering, and it's definitely not a good approach to support your business users, right? But then AtScale does it for you. So that's the autonomous data engineering part. That's how AtScale gets the performance, right? And then in Q4 of last year, there was virtualization capability that was added to the AtScale platform. And I will talk specifically about two key features within the virtualization framework that allow you to gain performance. One is the aggregate locality. What we mean by aggregate locality is like in the classic, in the previous slides where I was talking about big data and I was talking about cloud, and people are still trying to evaluate or how they're going to move data from big data to cloud. Can they do a hybrid approach? Regardless of how you end up architecting your solution, this key feature, which is aggregate locality, will allow you to still get the performance you need. Because what AtScale will do is, let's say you have you're connecting to the cloud and you have a on-premise data source as well. AtScale will intelligently promote the aggregates to the location where it feels that query performance will be optimal, right? So that decision making is driven by AtScale AI and ML engine. So you are inherently going to benefit and get the performance regardless of the approach you take in your data layer. The second part of virtualization, which I have mentioned on the screen, is the preferred aggregate location. Now, preferred aggregate location means you could actually choose to tell AtScale that Postgres is my preferred aggregate location. What that will do is AtScale engine will start promoting your aggregates to the Postgres database. Now there is some governance around what can be promoted, but the idea is that Postgres is very good at fast reads. So you are controlling the architecture for faster reads, and you are able to set the preferred aggregate location and say, let's store the aggregates here so we can get faster reads and hence get better performance. So the combination of those two features are very powerful, and that's how AtScale can help you achieve performance regardless of your data layer architecture. Now, why these features are very important as well today is because your data layer architecture landscape may be changing, right? It may be evolving, and you are abstracting the changes with these two key features. The other feature which allows for scalability and performance is the scalable query engine. The latest release of AtScale, which is 2020.2.2, allows you to have up to 5 scalable query engines. So you can achieve horizontal scaling and better serve your client queries, right? Just in terms of reliability and scalability, AtScale does allow you to have a clustered setup where you have more than one server in a clustered fashion. So your system is reliable and scalable at the same time. Let's go to the next slide. This slide, we are talking about cost savings, maximizing ROI, and cloud migration. Now, again, here, cost saving, as I said, is a huge component of the decision-making process. And especially with cloud, it's a recurring cost, right? So companies are very cost conscious, and they are looking at costs very diligently. So how does AtScale help with cost? Again, virtualization, preferred aggregate location. Now think of a scenario where you have migrated all your data to Snowflake. Now Snowflake is going to charge you for storage and compute, and the elasticity of Snowflake is good. But what Snowflake also does is, if you put the elastic nature of Snowflake in auto mode, if Snowflake, based on your configuration, needs to scale to support more queries, it will auto scale, which means you will be paying more. Now, depending on the workload, a single user or a combination or a very low number of user can cause your Snowflake or cloud cost to multiply dramatically in a short order. So how do you control that? Can you control that? The answer is yes, you can control that with AtScale's preferred aggregate location. You can control that cost. We have use cases where companies are using AtScale on top of Snowflake, and they have realized millions of dollars in savings. And we do have a ROI calculator when it comes to cost savings, projecting cost savings with cloud migration. And I would recommend that you connect with your CSM or AE and talk about cloud migrations. But how do we control the cost with AtScale? The preferred aggregate location. So imagine if you had all the data in Snowflake, and you also set up a Postgres database in the cloud or on-premise, doesn't matter, to store the aggregates. Now, what AtScale will do is, with the incoming workload, it will look at the queries and say, okay, I can serve these queries from the aggregates. So it will start hitting the Postgres database. So with the evolution of aggregates in AtScale, the traffic to Snowflake will be reduced, and the traffic to Postgres will be high. And that's how you achieve cost savings in a cloud environment. And as I said, we have calculators where you can key in the volume of data, the number of users, and so forth, and you can estimate the cost savings if you're migrating to the cloud. The other benefit of cloud migration with this particular feature is you can start moving your aggregates to the target platform as part of your data platform migration strategy. So if you are trying to migrate to Snowflake, you can have AtScale in the mix and start writing data to the Snowflake database, or you can start writing to the Postgres database, even if while you are trying to migrate from Hadoop to any of these other technologies, right? So there is no waiting. You can get started right away. The other benefit of having, or another feature which AtScale has and that helps with cost saving, is intelligent query routing. What I mean by that is, specific to Snowflake, you have all these small, large, and extra large data warehouses. You can configure AtScale to route smaller queries or to the smaller data warehouses, and the larger queries to the larger data warehouses. So you kind of controlling the workload that the Snowflake environments are serving, right? And you're doing that in a very autonomous way based on the AtScale AI and ML engine. So that definitely helps reduce compute cost. Finally, the universal semantic layer, it is very helpful. Like I mentioned previously, there are some traditional challenges we deal with when we are migrating data platforms. If you go with the traditional technology stack, you may have X number of reports or dashboards built over a period of time. And if you're migrating your data platform, then obviously those reports are impacted. There is, changes to the reports. There is regression. All that good stuff that needs to happen. Now with AtScale in the mix, you can lower your migration cost because there is an abstraction layer between the consuming application, which is the reports and dashboard, and the data platform, right? So you can definitely reduce the migration cost there. And finally, I think we try and make this or bring to our clients' attention that in some sense you are future-proofing your infrastructure. What we mean by that is today, as part of your cloud migration strategy, you may be trying to move to Snowflake, but in a few months, years, you may decide to move to a different platform, and that may require changes to your reports and dashboards, which can be challenging and costly affair. So with AtScale in the mix, you are abstracting those migration costs. Time to market. Again, the business wants the solutions as soon as possible. So some of the data engineering automation challenges can be very time consuming and complex. And with AtScale in the mix, you don't have to do data engineering. AtScale does it for you. And virtualization, again, if you're trying to move to the cloud or if you're trying to change your data landscape, you don't have to wait for data engineering efforts to bring data so that it can be consumed. AtScale will reach out to the data where it is and collate that data and present it to your business users in an expedited way. So that's how virtualization comes in very handy. From a user experience, yes.
Just wanted to tell you we've got about 5 minutes.
Oh, okay. So
Okay.
I'm probably going to, finish with this slide, and maybe we can take some questions after this. Let me just wrap this up. With the user experience, we do support OLAP, MDX reporting, and ad hoc analysis on relational data stores. People are able to connect through Excel, Power BI, and Tableau. And with virtualization, again, the user experience is consistent and transparent, regardless of any changes in the data layer, right? And with the universal semantic layer, of course, one of the key benefits is you are able to present data as information assets in a business-friendly way. So I'm going to pause there. I had a few other slides, but I'm just going to pause there, Carol, and see if there are any other questions, or else I can move to the next slide.
Yeah, you've been very thorough. I'm not seeing any questions from our audience. So if you want to keep going, I won't stop you.
Thank you. So let's talk about security very quickly. So from a security standpoint, AtScale does support LDAP, Active Directory, Google G Suite. We support SSL. We support SSO, SAML support for Design Center. That is the UI interface. And we also support row level data security, and we also support column level data security. So I think those are the slides which I had from a, from an AtScale key feature functionality standpoint. So if I go back to my first slide as we are wrapping up this conversation, as you can see, AtScale is actually allowing you to meet quite a few of the enterprise goals you may have in mind when you're thinking about deploying AtScale, or when you're thinking about how you deal with the changing data and BI landscape, right? AtScale allows you to get performance. It is secure. It is scalable in the sense that the autonomous data engineering piece, where we produce the acceleration structures, is elastic in some sense, right? Based on the queries and conjunction with the AI and ML engine, we will scale the number of aggregates. So your users will get the same performance regardless of the underlying changes in the data layer, right? There is governance built in with the universal semantic layer. And as I said, a lot of our customers, when they are moving to the cloud, they are realizing or maximizing their ROI with AtScale in the middle. Cloud can be costly, and AtScale is definitely playing a huge role in controlling that cost. And time to market is again another goal with AtScale, which you can achieve quickly, regardless of where your data is, regardless of whether it's on premise or in the cloud, in whatever shape or form your data is. You have the ability from AtScale universal layer to connect to those data sources, bring them in, and present it in a unified fashion to your business users for consumption via dashboard reports or for ad hoc analysis. So I'm going to stop there. I'm hoping that this presentation was helpful. I'm going to quickly go to one of the slides. As Carol mentioned in the beginning, we do have some upcoming presentations, which you will be notified. We will be talking about planning an AtScale implementation. How do you prepare your data for an AtScale implementation? The developing an AtScale queue will be more hands-on demo. And of course, finally, we want to wrap up with understanding AtScale cube deployment lifecycle. So I'm going to stop there, Carol. I thank the audience for joining.
Absolutely. Thank you everyone for your time today, and we'll see you on one of our new deep dive webinars very soon. Bye-bye.